In this video, I want to talk about the AC method. It's a method for factoring, and it's probably the most involved out of all of our techniques that we're going to learn, or maybe you've already learned the most advanced one we're going to review. Now, you're going to use AC method if you have a trinomial and the number in front, the leading coefficient, is not a 1, okay? So where A, B, and C are in the real numbers, but A is not 1, okay? And we also assume it's not 0, otherwise it's not a trinomial, right? So if it's not 1, we're going to have to use something else than we used before. We can't use leading coefficient of 1 anymore. So for the first example, I'm just going to show you how I would do the problem, and then we'll kind of dissect what I did. But first, I want to identify that this is not a leading coefficient of 1 problem. We have 3x squared plus 7x plus 2. I could look for a greatest common factor. I have 3, 7, and 2, but there's no way I can factor out the 3. So I have to come up with some other method. So I'm going to use what's called AC method. And why is it called AC? Because you take the A and the C and you multiply them. 3 times 2. Well, 3 times 2 is 6. And then the idea is that you find the factors of the AC that add to the B. Okay, so for this step, it's kind of like leading coefficient of 1. So what factors of 6 would add to 7? Well, I think 1 and 6 would add to 7. Okay. Now, this is probably the weirdest step out of all of the AC is once you find the factors, you have to break up the middle term plus 1x plus 6x plus 2. So 7x became x plus 6x because I identified that 1 and 6 were the factors I needed. And it seems really strange that I would turn a trinomial into now it's a polynomial. So what can I do? Well, now that we have 4 terms, we can factor by grouping like in the previous video. So I pick my pairs. So I'll pick the first 2 and the last 2. And then what do we have? I kind of wrote that sloppily. I'm going to rewrite that. What can I factor out of 3x squared plus x? I could factor out an x, and that's what I'm going to do. 3x plus 1. Okay. I have 6x plus 2. Out of 6 and 2, what can I factor out? I could factor a 2. 3x plus 2. All right. Whoops. What am I doing? That should be a 1. Sorry. So look at that. They are the same. 3x plus 1, 3x plus 1. I'm happy because that means I factor correctly. So I can factor out a 3x plus 1 and an x plus 2. Okay, so those are my factors, and now this is fully factored. I claim that if you redistribute these, you will get back the original trinomial, okay? But let's keep practicing this AC method. All right, I have 12x squared plus 13x plus 3. All right, is this a leading coefficient of 1 problem? Well, can I factor out a 12, 12, 13, 3? No, I can't factor out that 12, so I'm stuck with it. All right, well, if I'm stuck with 12, what am I going to do? I'm going to use the AC method. So AC would be 12 times 3, okay? Well, what's that? That's 30 plus 6, that's 36. What factors of 36 would add to 13, okay? What factors would add to 13? 4 and 9 would work, right? And then now comes the weird step where I break up that middle term, and it kind of feels like I'm making it more complicated because I am, but it's in hopes that I'll be able to simplify it in this way. So I'm going to pick my pairs, the first 2, the last 2. I'll be kind of lazy and just draw the parentheses around them. Now I'm going to factor within those groups. So I have 12 and 4. I can factor out a 4. X squared and x. I can factor out an x. So I have a 3 and an x I left behind plus 1. And then 9 and 3, I can factor out a 3. X plus 1. And look at that. This should have had a 3 on it. Look at that. The binomials are the same. That means we're doing good. So I can factor out 3x plus 1, 4x plus 3. Okay, again, I claim if you redistribute this, you'll get back the original trinomial. All right, what about 4x squared minus 9x plus 2? Is there a greatest common factor? 4, 9, and 2? No. So I can't get rid of the 4. I'm going to have to use the AC method, which would be 4 times 2, and that's 8. Now I need to find the factors of 8 that add to negative 9. Well, that's kind of weird. I have to find numbers that multiply to a positive number and add to a negative number. I think negative 1 and negative 8 would work, right? Those add to negative 9 and multiply to positive 8. So I break up negative 9 into negative x, negative 8x plus 2. And then I'm going to pick my pairs. The first 2 minus x. And then here, like in the previous video, we see that we have a negative sign. And my suggestion, if you ever have a negative sign in this right here, this term right here, go ahead and factor that out. And then we need to change the sign. Okay? Why would you do that? Well, through practice, you'll see that this will make both of the factors have the same signs, positive, negative, and that's more likely to get you the correct answer. Okay, so out of 4x squared and x, what can I take out? An x, so 4x minus 1. 8 and 2, what can I take out? I can take out a 2, 4x minus 1. Okay, these are the same, which is great, because that means I can factor them out, and I leave behind x minus 2. All right, so I claim if you redistribute this, you'll get back the original trinomial. In this example, we have 8x squared plus 2x minus 3. Is there a greatest common factor between 8, 2, and 3? No. So I'm going to have to use AC method because I can't get rid of the 8. So 8 times negative 3 is negative 24. Now I need the factors of negative 24, which add to positive 2. Let's see, 24's got quite a few factors. I'm thinking that that must be negative 4 and 6. If you add these together, you get 2. If you multiply them, you get negative 24. So I'll break this up. 8x squared minus 4x plus 6x minus 3. I'm going to pick my pairs. So I'll pick the first 2 and the last 2. Now, 8x, 4, so I can take out a 4x, it looks like. That would be 2x minus 1. And I can take out a 3, and that would be 2x minus 1. These are the same, which makes me happy, so I can factor them out. Plus 3. There we go. So I claim that that's fully factored. If you redistribute this, you get back the original trinomial. Okay, now we have 4q squared minus 5q minus 6. Is there a greatest common factor between them? Well, no. So I can't factor anything out. So I'm stuck with 4 times negative 6. Well, that's negative 24. Okay, I need the factors of negative 24, which add to negative 5. Well, it's not going to be 6 and 4. Looks like it's going to be negative 8 and 3 would fit the bill. So I have 4q squared minus 8q plus 3q minus 6. All right. So I can pick my pairs. So I'll pick the first 2, last 2. So I can take out a 4q. That leaves behind q minus 2. 3q minus 6. It looks like I can take out a 3q minus 2. And look at that. These are the same. So I can factor out q minus 2, 4q plus 3. All right, that's fully factored. Good. Hopefully the AC method is making a little more sense to you. Let's look at this example. So we have 12x squared plus 17x plus 6. Well, can I factor out anything? 12, 17, 6? No. So AC equals 12 times 6. Well, that's going to be 60 plus 12. That's 72. Okay. Now, what factors of 72 are going to add to 17? Getting harder now. 8 and 9 would work. So let's see. 12x squared plus 8x plus 9x plus 6. All right. Pick my pairs. So I got 12x squared plus 8x plus 9x plus 6. So I have 12 and 8. Looks like I can factor out a 4, an x, 3x plus 2. Then I can factor out of 9 and 6 a 3. So I have 3x plus 2. And look at that. They're the same. It means I did it right. So I have 3x plus 2, 4x plus 3. Okay. And now that's fully factored. All right. One more, just to be sure we got it. 36x cubed plus 3x squared minus 18x. Well, we've never dealt with one that has an x cubed before. It's always been x squared. So something certainly is going odd about this. Is there a greatest common factor that we can find between these three terms? Well, I think so. 36, 3, and 18, I think we can take out a 3. This is x cubed, x squared, and x. So it probably could take out an x, all right? If I take out the 3x, what do I leave behind? 12x squared plus x minus 6. Okay, so now I have to find how to factor this part. Well, I have 12, 1, and negative 6. I'm going to have to use AC method. So 12 and negative 6 would be negative 72. I need to find the factors of negative 72, which add to 1. Well, that'd be kind of like the last problem. Negative 8 and 9, right? So we're almost there. 3x. I'm going to use a bracket. And then I have 12x squared minus 8x plus 9x minus 6. Okay, now what can I factor out of this group? 12 and 8 looks like a 4x, 3x minus 2. And what about this group? I can factor out a 3. So that is 3x minus 2. And look at that, they're the same. So I can factor that out. 3x, then the 3x minus 2 from these factors, and then 4x plus 3. Okay. All right, well, that was a harder problem, but it's the same process. Okay. Again, I hope this helps. Let me know if you have any further questions.